So today we are going to work on graphing quadratic functions. So there are some 5 steps that we need to remember when we graph quadratic functions. The first step is we need to find the axis of symmetry. We need to find that x value because we need points to graph. So we are also going to find the vertex, and by doing so we need to plug that value in for what our x value is in for y. The third step is we're going to find the y-intercept. After that, we're going to need to find 2 more points, and then we're going to graph it. And we're going to graph by creating a mirror image because we understand that parabolas are the same on both sides. So let's start with step 1. So we're going to be using the equation y equals x squared minus 4x minus 5. So we are going to start by finding the axis of symmetry. So we're going to go back to that formula, which was negative b over 2a. And so I identified my a as 1 and my b as negative 4. And again, it's important that you focus on that it's a minus 4. So when we go through and solve, we end up with the minus of negative 4 over 2 times 1. When we simplify, we get 4 over 2, so x is 2. So that's our axis of symmetry, and we're going to make sure that we understand that because we're going to plot that on our graph as well. We are going to use this value, however, to find the vertex. So by doing so, we put that back into the equation. So I put in my value of 2 for all of my x's. I go through and simplify, and I end up that y is a negative 9. So my vertex now is 2, negative 9, and you'll note that there is a small mistake. It should be negative 9. So it should be 2, negative 9 is my vertex. So step 3 is my favorite step because it's the easiest. To find your y-intercept, it's your c value. So we have y equals ax squared minus or plus bx minus or plus c. So in this equation, c is my last term, so it's negative 5. So my y-intercept becomes negative 5, or 0, negative 5. So I now have 2 points that I can graph. So I need to find 2 more. So since my x-axis is 2, I want to choose values that are less than 2, because I already know that side, so I want to make sure I'm choosing values that are less. So I chose 1 and negative 1, because quite frankly, they are the simplest ones. Again, you just put in your values for x. So when I go through and solve, I end up with 1, negative 8, and negative 1, negative 5. So I now have 4 points that I can graph. So I'm going to talk through my graph. It's already done, so we're just going to talk about the basic points. So the first thing I did is I plotted my axis of symmetry. So my axis of symmetry is x equals 2, and it's a dotted line because it's not quite a line, it's really an imaginary line that splits it in half. I automatically started by plotting my vertex, which is down at the bottom, which is 2, negative 9. I then used my other points. So I found a point that was 1, negative 8, which is over here. My y-intercept, which was 0, negative 5. And then my other point, which was negative 1, 0, when I went through and solved. So if you see, I have points on this half. Like I said, it's a mirror image, so what you end up doing is you have to reflect it across. So if this one is 1, I usually kind of count the units. If this one is over here at 1 unit, then this one has to be on this side at 1 unit. If this one is over here 2 units away, this one has to be 2 units away. If this one is over here at 3 units away, then I need to make this one over here at 3 units away. And so by doing so, you end up with a mirror image of points. So this ends up being negative 1, 0, and this one ends up being 1, 2, 3, 4, 5, 0. So again, reflecting across the x-axis. So when you use the axis of symmetry to make a mirror image, you end up with a graph. It's 5 steps in order to graph this equation. You have your vertex, you have your axis of symmetry, you have your 3 points outside, 3 points on the other side. And that is how you graph a quadratic function.